So, first of all, your answer should have been this. Tangent squared. All right. So let's look at y. We're going to start with, we have secant squared x over cotangent squared x plus 1. This guy right here should look very, very, very familiar. All right, cotangent squared plus 1 is a Pythagorean identity. What does cotangent squared plus 1 equal? Cosecant squared. So I have secant squared of x over cosecant squared of x. That's cosine. Cosecant squared of x. All right. So now I'm actually going to rewrite this in sine and cosine. I'm actually using two methods here because this doesn't look as simplified as I possibly could get it. So I am going to simplify it a little bit more. What is secant if I rewrite it as sine or cosine? 1 over cosine squared, right? And if it's secant squared, it's going to be cosine squared, okay? What is cosecant squared if I rewrite it? 1 over? How do I treat fraction over fraction? What's my little rule? Keep, change, flip. So I can say this is the same thing as 1 over cosine squared of x times sine squared of x over cosine squared of x. Right, and then 1 times sine squared is sine squared. What? Oh wait, that's cosine. Yeah, this should be a 1. I was getting ahead of myself and going straight to the answer, sorry. This is cosine squared times 1 is cosine squared. What's sine over cosine? Tangent. And since it's squared, it's going to be tangent squared. Okay, this is identical to the last one that we did, where you're saying your common denominator is just going to be these two guys multiplied. So my common denominator is going to be tangent x times 1 plus cosine x, right? And then my numerator is going to just multiply across. These two multiplied, so I'm going to say 1 minus cosine x times 1 plus cosine x. And then plus, because that's what's there, plus. And then I'm going to multiply this guy across there. Tangent of x times sine of x, right? So far, so good. All right. And then now I'm going to try to simplify. This is a special case. It's a plus b, a minus b. All right. So it's the first one squared. So that's 1 squared, which is just 1, minus the second one squared, which is cosine squared of x. Alone for right now. So plus tangent x sine x over tangent x 1 plus cosine of x. All right. So then this part right here should look somewhat familiar. Sine squared of x plus cosine squared of x equals 1. If I subtract that over, sine squared of x equals 1 minus cosine squared of x. Yes? All right. So I'm replacing this piece right here with just what? So sine squared of x plus tangent x sine of x all over tangent of x 1 plus cosine of x. Questions so far? What can I do now? So you can factor, and that's what you would do here. You would factor. Let me see. So I'm going to take my sine of x out. And I have this is like a weird one. All right. So I'm going to rewrite this part, this pink part right here, using that information that I just did. So I basically reduced these guys here to be just cosine. All right? Yes? And then what I'm going to do is I'm going to rewrite this tangent as well to sine over cosine. So now I've reduced this to just cosine. So on the top, I just have cosine. Here I have sine of x plus sine over cosine of x. Just trust me on this, right? And I'm going to leave the bottom. Remember, I canceled my tangent, so I just have 1 plus cosine of x. Yeah, so far so good. Other than y'all hate this problem, but yeah.
But this will not like be on our...
Not one quite this complicated, but hopefully you're following me.
Yes.
All right? Now I'm going to distribute my cosine, okay? So I'm going to distribute my cosine through, all right? So I have cosine. We could have done this back there, but I didn't realize they weren't going to cancel it. Now what happens when I multiply this cosine over here? What actually happens? My cosines cancel, and I have just sine of x there. Everybody see what's happening here?
Yes, but
All right. Now what can I factor out on the top? No, on the top, what's in common? Sine of x, and we have cosine of x plus 1 over 1 plus cosine of x. It's addition. So cosine plus 1 and 1 plus cosine are the same thing. If it were subtraction, I would have to factor out a negative. But 2 plus 3 is the same as 3 plus 2. Order does not matter when it's addition. So I can actually cancel this with this. And my answer is sine of x.
all that to just say it's
So the reason people like verifying better than simplifying is it tells you where you're going. Okay? So it wants you to show me step by step why these do indeed equal each other. Which means I kind of know where I'm headed. Now, you must head there logically, because you can't just like do a step here and there and then say it equals, right? Like, no, that's not. I'm going to look for, did you logically prove this? But it gives you a direction. You know when you're done. Whereas simplifying, like we got to like secant squared over cosecant squared. And that looks pretty simple, right? But you can go a step further with secant squared over cosecant squared. And so we went a step further with that. And so sometimes with simplifying, people are like, I don't know where I'm going, so I'm not sure when I'm done.
Oh, so
This one is saying, hey, these two do equal each other. I want you to prove it, okay? And so the method you're going to use is you leave the simple side alone, because there's not much more you can do to cosine squared. You can change it into secant squared, 1 over secant. That doesn't help, right? And so working backwards with these is not a good idea. You want to take the most difficult side, leave the right side alone, simplify the most difficult side until you get to what the right side tells you it is. And then you have verified it. Okay? So this just is exactly what we just did, but it kind of tells you where you're going. You're verifying. Okay? So you still have to know your identities, right? But then we are going to kind of know where we're headed. All right, so we're going to get our little identity sheets, right? And you're going to keep those beside you at all times except during your quiz. So verify this. Which is the most difficult side? It's kind of right there. Definitely the left side, right? So of that side, something should be standing out right now. Something should be standing out to you. Yeah, you have a trig function with a squared with a 1. So that should take you straight to Pythagorean identities. The Pythagorean identity that deals with cosecant squared is cotangent squared plus 1 equals cosecant squared. I need cosecant squared minus 1. Minus 1. So if I just subtract my 1 over, cosecant squared minus 1 equals cotangent squared. So I'm going to replace that numerator with cotangent squared. All right. Now at this point, I have a cotangent squared and a cosecant squared. I personally would rewrite everything in sine and cosine. Right now is where I'm going to say, okay, there's really nothing more I can do. If I go backwards and put the 1 plus, that's not helping me. I'm getting more complicated. So now I'm going to do my method of replacing with sine and cosine. So how would I rewrite cotangent in sine and cosine?
Cosine over sine.
Cosine over sine. And so it's cosine squared over sine squared. How would I rewrite cosecant squared?
1 over sine x.
1 over sine squared. How do I do a fraction over a fraction? Keep, change, flip. Keep the first one exactly the way it is. Change it to multiplication. Flip the second one. What can I do between these? I can cancel, cross cancel. Cosine squared of x. Yes. I just verified it. All right, so we are going to do the butterfly method again, okay? We are going to multiply our denominators, right? So this is going to become our denominator. So I'm going to say we're dealing with a difficult one always. So cosine of x plus cotangent of x times, or sorry, cosecant of x minus cotangent of x. Then we are going to multiply across. So we're going to take this base and that will be multiplied across over there. So on the top we have cosecant of x minus cotangent of x. It is a plus, so we're going to say plus. Then we're going to multiply across this way. 1 times that is going to be cosecant of x plus cotangent of x. All right, it is the same exact thing, but it's plus minus.
Yeah,
Wait, but isn't that the same thing?
See that these are the same exact things, it's just a plus minus. Yes?
Yeah.
So that means that we have on the bottom, we have cosecant squared minus cotangent squared. On the top, we have cosecant minus cotangent plus cosecant plus cotangent. Combine your like terms because it's all it is. So we have cosecant plus cosecant is 2 cosecants. And that's actually all we're going to have. 2 cosecants. And then we have a negative cotangent and a positive cotangent that zeroes out. All right? Now, cosecant squared and cotangent squared do have a Pythagorean identity. So let's off to the side, let's look at that Pythagorean identity. What is the Pythagorean identity that deals with cosecant and cotangent? What does it look like?
Cosecant squared is cotangent.
It's cotangent squared plus 1 equals cosecant squared. All right? I want cosecant squared minus cotangent squared. right? I want cosecant minus cotangent squared. So how do I get cosecant minus cotangent squared? I need to move cotangent squared over, right? So it's 1 is going to equal cosecant squared minus cotangent squared. Everybody see that? I just moved it over. So what can I replace cosecant squared minus cotangent squared with? 1. So I have 2 cosecant over 1. What is anything over 1? It's just itself. 2 cosecant. Lo and behold, that's what I was trying to find. I have verified it. So I'm going to show you this method because we're going to finish this method tomorrow. The most difficult side here is most definitely the left. So we have sine of x over 1 minus cosine of x. Nothing here is intuitive. In order for 1 minus cosine to help us, he needs to be squared. There's a way for me to get him to be 1 minus cosine squared. I create the a plus b, a minus b. So I need this bottom to be a Pythagorean identity. So I'm going to multiply by what is the opposite there. If I have the a plus b, I'm going to multiply by the a minus b part, okay? So I'm actually multiplying top and bottom to force that guy to be a Pythagorean identity on the bottom. So on the top, I just have the sine of x times the 1 plus the cosine of x, right? And on the bottom, I now have a plus b, a minus b, 1 minus cosine squared of x, which again should trigger this little guy here. sine squared of x equals 1 minus cosine squared of x. So I can replace this with sine squared of x. And I have sine of x times 1 plus cosine of x over sine squared of x. That's a beautiful 2. All right. One of my sines can cancel, right? So I have 1 plus the cosine of x over the sine of x. I'm still trying to get cosecant and cotangent. So I can split that numerator. This is how fractions work. 1 plus 2 over 3 is 1 over 3 plus 2 over 3. So this can be split to 1 over sine of x plus cosine over sine of x. What is 1 over sine of x? That's a reciprocal function. 1 over sine is cosecant of x. What is cosine over sine? Cotangent of x. What was I looking for? That I have verified it. All right, so these are just 2 more examples that we haven't done yet, but we've done this process in simplifying, just not improving. So again, anytime you have an equals sign with these, your process is going to be to verify, which means you only work with one side, okay? You only work with one side. So I am going to pick out the most difficult side, which I think everyone would agree this guy is the most difficult side. All right, so there we go. I think he's the most difficult, don't you? So we'll deal with that side. All right, so we have cotangent of theta, secant of theta, cosecant squared of theta minus cotangent cubed of theta, secant of theta. Let's write one more trig function if we can. Here's what I'm going to say. What do I have in common between both of those? What do I have in common? I have a couple things, don't I? I have a cotangent in common. I can take one of those out, right? So I'm going to take out a cotangent. What else do I have in common? A secant. So I'm going to take out a secant. Nope. I'll write with not. All right. Secant of theta. All right. And then what do we have left over? Well, we took out a cotangent and a secant here. We are left with cosecant squared. I took out my secant here and one of my cotangents. So minus cotangent squared of theta. This should trigger something. I have cosecant squared and cotangent squared. What identity is going to lend itself to cotangent squared and cosecant squared? Yeah, Pythagorean identity. Cotangent squared of theta plus 1 equals cosecant squared. I want cosecant minus cotangent. So just move your cotangent over, right? So what do I have? 1 equals cosecant squared of theta minus cotangent squared of theta. Everybody see that? So I'm going to replace this whole guy with just 1. That's easy. What am I left with? 1 times anything. I just have cotangent of theta, secant of theta. All right. Now I'm trying to get to what? Like at some point you're like, this is the thing with simplifying. When you simplify, you would be like, how much further can I go here? So if I were simplifying this, I would actually still see if I can do anything else in sine and cosine, right? That's what I would do. This tells you you're not done, correct? Like I know I'm not done because I haven't gotten there yet. So my next step here is definitely sine and cosine. Sine and cosine. All right. So what is cotangent in sine and cosine? It's whatever tangent, but just if I put it both in sine and cosine, it would be what? In my quotient identities. Cosine over sine. At the very top of your page there, it's cosine. And that one's kind of easy to remember. Cotangent is cosine on top. Okay. So we have cosine over sine here. What is secant? 1 over cosine. Those are opposite, by the way, of how your brain would want to do them. 1 over cosine. Now, what can I do? I'm multiplying fractions. I can cross cancel, can't I? So my cosine and my cosine will cross cancel, and I end up with 1 over sine of theta, which equals cosecant We are done. We have proven it.